Sir, you can start, please.
Yes, good evening, everyone. How are you? Good, good. So, tell me very fast that what we discussed in the last lecture so that we can continue. I'm little bit unwell, so please tell me fast. What topic we discussed in the last lecture? Nobody's there to tell me? Hmm? Okay, so let's start the session now. So, good evening, everyone. Once again, we are here to start the new chapter that is related to semiconductor material and its application. So first, we will understand what is semiconductor material, how we can develop it, because we have types of semiconductor material, and where do we use that. So we will discuss about the application of semiconductor material. So these are the common guidelines that you all have to follow it. So please maintain discipline, attendance. All are the same guidelines. Please follow it. So these are the learning objectives of the today's session that you will be able to understand what is semiconductor, its types and application. So after understanding, you will be able to do this. We will understand what is energy gap, right? Energy gap means the gap between two bands. Okay, so we will discuss about all insulator, conductor and semiconductor material. You will also understand the concept of p-n junction diode and its conduction property. P-n junction diode is a switch that we generally use in electronic circuits, and how p-n junction diode works. So we will understand the behavior, right? So let's start with the matter. So what is matter? So matter is nothing because it is already studied in science. So matter is nothing that occupies some space and should have some mass. Okay, so anything whichever is having mass and occupies some space is known as matter. So material is named after this matter. Okay, So material is actually matter, and matter is what? That is that occupies some space and should have some mass. Okay, and how we can see inside the matter. So if we do the research on matter, then what we will have? We will have molecules, right? So inside matter, there will be many molecules that we have studied in science. We have studied this thing in already in science, so we will not go in the depth, but we will discuss a little bit. So if we see in the matter, there will be many molecules, right? And if we take one molecule, so what will be inside molecule? That will be atoms, right? And whenever we do the research, okay, so there will be curiosity to know more about that. So after getting about the molecule, there was curiosity to know about inside molecule. After getting atoms, we will have curiosity to go inside the atoms. So whenever we see in the atoms, there will be nucleus and electrons. So what will we say? There will be one nucleus that is known as center, and in various orbits, circular paths, electrons were moving like this. So it was having nucleus was having protons and neutrons, and these are the electrons. So this is known as Bohr's model. So it was actually developed by Bohr. Bohr was a scientist. So it is known as Bohr's model, in which he discovered that inside one atom there was one center that is known as nucleus, and some electrons are moving in the circular path that is known as orbits. Okay, and inside the nucleus, what he saw that there are protons and neutrons. So in atom, the basic elements are protons, neutrons, and electrons. So these are the three basic elements which are making one atom. Okay, so in one atom there are protons, neutrons, and electrons, in which protons and neutrons are in the center, that is known as cell, nucleus, and electrons are moving around that nucleus in circular path, that is known as orbit. So that was the structure of one atom. Okay, so you can see here, matter is nothing but the group of molecules, and molecule is the group of atoms, and inside atoms there was nucleus, and neutron protons are part of nucleus. Okay, and electrons are revolving around the nucleus in many orbits. Okay, so whenever we give the energy to the matter, so this energy is actually gained by electrons. So these electrons are in outermost shell. After getting energy, these electrons will become free. So whenever we talk about the current, okay, so current is what? That is the flow of electrons. But that flow of electrons, just a minute, please wait. Okay, so whenever we talk about the current, that current is the flow of electrons. So that electron is not electron, it is free electron. So if nothing is free, then how it can move? If it is not moving, then how the current will flow? Okay, so that electron should be free. So free means these electrons are moving in the orbit. It means they are bounded, they are bind with something that is known as covalent bond. Okay, so we have to free these electrons from the covalent bond or from this atom. So this external energy is required. So after getting the sufficient energy, right, they will become free, and that free electron will be the part of current. Okay, so free electron means this electron that is in outermost cell. The electrons which become free were actually moving in the outermost shell. Not this electron cannot become free because this is nearest to nucleus, and nearest to nucleus means this is tightly bound. It is completely attracted by the nucleus. Okay, so the electrons which are free or becoming free are in outermost cell. So outermost cell electrons are playing in any of the reaction or process. Okay, so this is all about the matter, but this matter can be classified into three types on the basis of conduction. So we have three materials: conductor, insulator, and semiconductor. Okay, so conductor is what? Conductor is the material in which the flow of electron is very easy. It is easy. But in insulator, it is impossible. Impossible. It is not possible. The conduction is not possible. Conduction of impossible means the flow of electron is not possible. And semiconductor, so semiconductor is that type of material which is falling between conductor and insulator. Okay, that means we the conduction is neither easy nor impossible. Means the conduction is possible, not but not easy. So it is neither conductor nor insulator. So it is falling between both, right? So not easy, right? The conduction is not easy, but possible. But possible. Are you getting? So have you all understood what is the classification of material? So it is divided into three types. First is conductor, second is insulator. Conductor is the material in which the flow of electron is very easy. It means the current can flow very easy. Right? Insulator, the flow of electron is impossible, means there is no conduction. But in semiconductor, it is not easy but possible. Okay. So on the basis of conduction, we can classify matter into three types. Understood? Any doubt to anyone? You can ask me. Okay. So this is that model that is known as Bohr's model. So Bohr proposed the atomic model in which electrons are moving in circular path or elliptical path, right? And nucleus is in the center. So after discovering it, the electron which is moving around this circular path is having mass this. So one electron is having mass 9.1 into 10 to the power minus 31 kg. So it is very very less. Okay, but it is having some mass. That is why it is the part of material. That is matter. Okay, and whenever we talk about the electrons, so what we understood, that it carries some charge. So what is the value of charge? So it is actually 1.6, not 1.9. So 1.6 into 10 to the power minus 19 coulomb of one electron. 1.6 into 10 to the power minus 19 coulomb, that is the charge of an electron or one electron. Got it? So these were the values proposed by Bohr, and what he saw, that number of protons, how many number of protons was there, was the value of atomic number. So every material has atomic number and atomic mass. You might have studied periodic table in chemistry. Okay, in science, periodic table is there in chemistry. So every material, suppose A material is there, then X is the atomic number that will be written here, and Y is the atomic mass. So whenever you study about the periodic table, then every material is having this type of explanation. The short form or short name of that material, like hydrogen, so H will be there. Helium, then He will be there. Right? Silicon, then Si. Carbon, C, like that. Okay. So there will be 6, 12. So this 6 is the atomic number of the carbon and 12 is the atomic mass. Clear? So in this way, every material is mentioned there in periodic table. So what he saw, that the number of protons is equal to atomic number. So if we talk about the carbon, there is 6 atomic number. So 6 protons will be there in carbon atom. Clear? And it will be equal to electrons also. So 6 electrons will be there. Proton number of electrons is equal to number of protons is equal to atomic number of the material. Okay, so three values are same: number of protons, number of electrons, and atomic number. So these three values are same. So if you have any one, say that this number will also be this, right? And what about atomic mass? So proton plus neutron is equal to atomic mass, right? Clear? So this is the relation between proton number, neutron number, electron, atomic number, atomic mass. Clear? So if you don't have number of protons, you can use the value of number of electrons, atomic number. Clear? So we have these three relations. So you can remember it. So you can see here nucleus is there. So what is inside the nucleus? Neutron and proton. And electrons are moving around the nucleus. So this is Bohr's model that he proposed after discovering about the material. Any doubt to anyone? Have you understood? This is the part of chemistry actually. You should have studied in chemistry or science basically. Right. Now we come to the energy band gap. So what is energy band? Okay. So energy band gap, right? So you know what is gap? We generally use this word gap. So there is gap between this and this. Okay. So this means the distance. Gap means the distance from this point to this point. This is the band gap. But what is energy band gap? So you can understand from the name. So name suggests that energy band gap is the distance or gap equal to the energy which is required for anything, for what we will discuss. But in general, we will say that this is the gap of the energy which is required for anything, right? So for what? We are talking about the electron. So this is the energy gap which is required for an electron, for one electron to do something. So what we have to do, we will understand here. So if we see inside the material, there will be two bands. Okay, for any material, if whether it is conductor, insulator, or semiconductor, there will be two bands. One will be valence band, and second will be conduction band. Right? So there will be two bands, valence band and conduction band. So what the study says? Study says that all the electrons, whatever the number is, all the electrons are initially filled in valence band. All are in valence band. So if we say there are two rooms in our home, right? So all are sitting in one room, and we have closed the door. So what will happen? If anyone comes from outside, he will say there is no one, there is no movement in the home, right? So, but we want the flow, we want the movement in the house. Why? Because there should not be silence, right? So similarly, if we talk about the material, there should be conduction. So conduction is what? The flow of electrons. So electrons should flow inside the material properly. So this is our motive. So same thing is there. There are two bands. One room is valence band, second room is conduction band. So conduction band, the name is already showing that conduction band is that band after which the conduction will be started. So for conduction in the material, conduction band should be filled with the electrons. Filled means at least one or two electrons should be there. So what we have to do, we have to shift the electrons which are inside the valence band to the conduction band. Then after the conduction will be started. Okay, so how we will show it? So we will draw like it. This is valence band. I am writing in short valence band, and this is conduction band, right? So we have just draw like this. And what is this? What is this gap? This is the energy gap. Why we are showing this gap by energy gap? Because the electrons which are filled in valence band want to move to the conduction band. So if you have bike and you want to go somewhere, so there should be petrol in the bike, right? So after filling the petrol, it will get the energy and can move. Similarly, for an electron, the energy should be given to it, and after gaining the energy, it will move from valence band to conduction band, right? So this gap is showing that this is the minimum energy which is required for an electron to shift from valence band to conduction band. Clear? So this that is why we are writing energy and G for gap. So this is the gap of the energy which an electron gains and can move from valence band to conduction. And after reaching in conduction band, if this electron is reaching in the conduction band, then after the conduction will be started. So conduction band should have electrons so that it can start conduction in the material. So this is our motive. So if we see in insulator, right? Just a minute, I am removing this. Sorry. Right. So in case of insulator, this energy gap is greater than 5 electron volt. 5 electron volt EV. And this energy is too much that one electron cannot gain, cannot have, right? So if suppose you have filled the bike fill the tank of bike with the petrol, and that can means you can travel 500 kilometers, for example, but you have to go 520 kilometers, right? So after filling one time tank, it can travel 500 only, but you have to go 500, more than 500, for example. So can you reach there? No. The same thing is there, that one electron, how much the energy that is gained by one electron is not sufficient for jumping from valence band to conduction band. So it is too much, right? That is why the conduction in insulator is not possible. Clear? And if we see in conductor, right? If we see in the conductor, this is the valence band and this is the conduction band. And this space is common, means overlapped. So due to overlapping, right? The electron can move anywhere from here to there. Okay. So free means electrons are very free to move anywhere within the material. That is why in conductor the conduction is easy. Clear? And in case of semiconductor, I am just showing here. In case of semiconductor, this energy gap is approximately equal to 2 electron volt or less than. It is less than or equal to 2 electron volt. So this energy is less that one electron can gain easily. Okay. So there is gap, but not very high. It is very less, and this gap can be filled very easily after giving some energy to electron. So the electron which was in valence band here will gain the energy, the sufficient energy, and will shift from valence band to conduction band. And after reaching there, the conduction will be started. So this is the energy band gap of insulator, this is the conductor, and this is the semiconductor. So have you all understood what is energy band gap? How the conduction is possible or impossible in the material? We can understand from the energy. Have you all understood? Are you getting what I'm saying? Okay. Anybody, any problem, any doubt, you can ask me. Otherwise, we will start the next diagram. Here, we are actually showing this completely as valence band because within material they are levels, bands, different bands. So we are considering this first band, second band, and valence band as completely valence band. So initially, all the electrons are filled in valence band. Okay, and this diagram is showing that the electron is becoming free. How is it free? We have applied some energy in form of heat. Okay, so after gaining the heat energy, this electron becomes free. And whenever the electron is becoming free, then there it will leave some space. If you are sitting on the chair and you stand up and go somewhere, then that seat will become free, means there will be vacant space, and that vacant space is known as hole. So whenever we are saying that one electron is becoming free, right? So there will be electron hole pair. So always electron hole pair will be generated. Clear? So if electron is becoming free, it will leave some space, and that space is known as hole. So what is the role of hole electron? We will understand in the types of semiconductor. Okay. So hole and electrons will be used as charge carrier. Okay. So it will be understood in PNN type material. Got it? So these are the same diagrams that we have already discussed. In case of insulator, it is very large. In case of semiconductor, it is small. But in case of conduction, conductor, this is overlapped. Yeah? So we have already discussed all these diagrams in detail. Clear? So there is no need to explain again. We have already discussed. Now we come to the types of semiconductor. So first we should know semiconductor. So semiconductor is the material which is falling between, which is neither conductor nor insulator, and having four electrons in outermost shell. So in periodic table, there was six number: carbon, Ca, Sun, Perf. Right? So these were the materials in this sixth line. Sorry, four. Right? So in case of carbon, what was the atomic number? 6. So if we divide it to 4, right? 6 is divided as 2, 4. So there will be 4 electrons in outermost shell. Clear? So for any of the material, if you divide it, there will be 4 in the end. So 4 electrons will be there in the outermost shell. Got it? So these are the electrons which are actually playing the role in conduction. Clear? So you can see here that everywhere. So this is the structure of germanium. This one. Clear? So you can see here that is 32. So this 32, if we divide it, there will also be 4 in outermost cell. 4. Recording. Just hold on. So in germanium, there are 32 electrons in total. So if we divide it, there will also be 4 electrons. Okay? But what is the motive? Everyone wants to be stable. Stable means there should be 8 electrons to make octet. So there are 4, but we want 8 to make it stable. So 4 electrons are required. So you can see here that this germanium has 1, 2, 3 and 4 electrons of it, and another atom of germanium is 1, one of this, one of this, one of this. So it is making 8. Similarly for this, there will also be 1, 1, 1, 1, right? Like this. So same structure will be expanded one after another. Yeah. So what we want? So this is actually pure semiconductor. Pure semiconductor. So if octet is completed, so whether there will be conduction or not, can you imagine? There will be no conduction. So because the electrons are not becoming free, so we want to make free electrons, right? So we will mix something, and mixing is known as doping, right? So doping will be done. So what type of doping we will do? So we have another type that is known as extrinsic. So in intrinsic means pure semiconductor, right? So pure semiconductor means like germanium, silicon. We use basically two material out of those six, silicon or germanium. So it is having 0.72 electron volt and 1.1 electron volt energy gap. So it is very less, right? So we will make it more conductible. So what we are doing, we are mixing something. So doped, we have doped the impurity, impurity, and impurity are of two types. Two types impurity will be done: pentavalent and trivalent. Pentavalent means the material having 5 electrons in the outermost. Trivalent means 3 electrons in the outermost, right? So after doping or mixing pentavalent, we have N type. After doping trivalent, we have P type. So P type and N type are not the type of semiconductor. The types of semiconductor are intrinsic, that is pure semiconductor; extrinsic, that is doped pentavalent and trivalent impurity are doped. Then we have two types of extrinsic, N type and P type. So N type is developed after doping pentavalent, and P type is developed after doping the trivalent impurity with the pure semiconductor. Okay. Any doubt to anyone? Any doubt? Understood or not? Yes, Jishu. Please tell me. Write in the chat what do you want. Jishu Khan, you can write in chat. Jishu, write in chat, please. Are you writing? Jishu Khan, please write if you have any doubt. Otherwise, we will proceed. I want to write this notes. You will have the video, recorded video of the lectures, right? If you want to write something, write in short in copy or register. Okay? No need. Try to understand. Don't waste your time. Something. You listen carefully and understand. Okay? And still you want to write something, write in short. Right? The key points, keywords. Okay? Then Ramesh, this is very difficult. Why? It is very easy. You just go into that and select the subject, and inside that subject you will have the video. Okay? Okay. Now we understand what is N type or P type. So what I told you that the pentavalent impurity is dope. Sorry. So we have pure semiconductor having 4 electrons. After doping we have 5. So what is there? 9. But what is the requirement? That is 8. So beyond octet we have 1 electron. One extra electron. Extra electron. This is extra electron. And this extra electron is actually the free electron because there is no space. Suppose you having 8 chairs and 9 persons are there. It means 8 will be sitting on the chair, one will be standing. He is free actually, so he can move anywhere. So that extra electron is actually the free electron which will play the role in conduction. Remaining 8 are stable. Okay. So in this way, this electron is generated, and this type of material is known as N-type. This electron will be accepted by the another material whosoever require 1 electron. Okay, so there will be material, we will understand it. So it means it is giving 1 electron. It is giving 1 electron. So this type of ion is known as donor ion or donor atom. Donor means who donate something. Okay, so donor atom is there because free electron will be given to someone. Okay, clear? So you can see here we have semiconductor pentavalent. We have doped 5 electrons in its outermost shell. 4 out of 5 are used to form the covalent bond. So it has make octet. 1 electron will act like 3 electrons. Understood? So whatever I am telling is written there. Similarly for p-type, so this is the structure how it is being done. Germanium was there, right? So this is atom of germanium, this is atom of antimony. This is the atom of G, this is Sb, GeSb, this GeSb. But this excess electron of Sp is there because it is having 5 electrons in the outermost. So whenever we mix anything, there will be reaction. Okay, so reaction will be done between outermost cells electrons. So Ge has 4, Sb has 5. So these 4 of Sb will be reacted by them like this, right? 8 are there, but one electron, one is this. This is one electron. So this one electron is in excess. So we will show like this. Clear? Similarly for p-type semiconductor. In p-type semiconductor, we have to actually convert. So I am just telling you, in p-type semiconductor, 4 electrons are in pure semiconductor and 3 are in trivalent. So there are 7. It means it cannot complete octet. So one space is there, vacant space is there, right? So this vacant space is known as hole. So this hole is the charge carrier for p-type, while electron is the charge carrier for n-type. So there are two types of charge carriers, electrons and holes. Electrons in n-type, holes in p-type. Okay. So in case of n-type, electrons are the charge carriers. So we can classify as majority and minority. So in n-type, electrons are majority and holes will be minority. And in case of p-type, holes will be majority and electrons will be minority. Opposite. Okay. Electrons are majority in n-type. Holes are majority in p-type. Opposite will be minority. If electrons are majority, then holes will be minority. If holes are majority, then electrons will be minority. Got it? So this is the p-type and n-type semiconductor material. So you can see here, right? This is for GE, this is for GE, this is for GE, and this is also for GE. But for B, one electron, two electron, and three. For boron, it is one, two, and three. There is no fourth electron, so this is hole actually. Vacant space. There will be vacant space in this case. Okay. I hope you understood this thing. Any doubt to anyone? You can ask me. No problem, Dishu. You just see the videos and everything. Watch the recorded lectures, and will understand. I think. Okay. Any doubt till this point to anyone? Okay. Now, after developing p-type and n-type semiconductor, we will join it. We will join it. So one thing was left here. In case of p-type, this is hole. Hole means vacant space, and vacant space means if you have vacant chair, then you can offer someone, please sir, please sit. Okay. So you can offer if you have the vacant seat. Otherwise you cannot. Okay. So this vacant space will be occupied by something. It means you are accepting one electron to fill that vacant space. So that is why it is known as acceptor ion. In n-type, that was donor ion because one electron was in excess. That is why it could donate. But here there is one vacant space. It means we will accept one electron. So this is acceptor ion. So this will be shown here. P-type acceptor means we will accept, negative will be there. Donor means donate, they will be positive. So you can see here, this is positive, this is negative, right? And above this, because this is negative means acceptor. So acceptor means they will be whole. In donor there will be electron, so we will draw like this. Clear? So we can make like this. This is p type, this is n type. I have drawn something like this. This is plus. Okay, so this plus or minus is showing whether it is donor or acceptor. So we will draw holes here like this. These are the holes of p type, and these are the electrons. Okay, so whenever we join both of the materials, then it will become p-n junction. P-n junction. Junction means where two things are meeting. So this is the junction J where both are meeting. Once we meet both, one has one electron, a second has vacant space. If person is moving and get the vacant seat, will sit on it. So similarly, if this free electron is there, vacant space is there, then he will sit on it. And once it sit, it will become neutral. So this, after becoming neutral, so this hole which was above that head will be removed. So we will remove like this. So we will remove it, remove it, right? So in second stage, we will remove these electrons and holes. How many electrons and holes will be removed? It is the process until unless more electrons cannot shift. So what we are saying that the electrons and holes are moving from this to that and that to this, and it will react with each other. We will use the word recombine. So recombination will be there. Okay. So after recombination, plus minus neutral, plus minus neutral. So it will become neutral, and neutral will be known as. So before this, it was mobile charge carrier, and after removing it, it will be known as immobile charge carrier. Right? So mobile charge carriers can move, immobile charge carriers are stable, it cannot move. Clear? So this is the process in which we know. So now after this, we will connect one wire here, one wire here. So this is known as positive, this is known as negative, right? So in this way, we can develop the PN junction diode. So this is known as PN junction diode, and the symbol is like this triangle, one bar like this. So this is actually showing P type. This is showing. So I hope you all have understood. So what we discussed about the semiconductor, its types, What is energy gap? We have discussed about energy gap of insulator, conductor, semiconductor, right? How we can develop p-n junction diode, है ना? How it will behave. So behavior will be understood in the next session, because in that we will understand how does it work. Okay, where we can use it. So we will understand this all in detail in next. So these are the learning outcomes that we have already discussed about that. So if you have any doubt, you can ask. Okay. Minal, you didn't tell me in the beginning. I told you to remind me. Okay. You did. When? When you? I could not see. Just a minute. Where did you write? I asked so many times what we discussed in last session, but nobody wrote anything. I started the class because I cannot wait for more time. Where did you write? Yes sir, yes sir. No, Minal. Minal. Minal, your first message was at 4:17. Yes. Before that, you didn't write anything. No. No problem. I'll explain next. Whenever you say, I'll explain. Right? No problem. Okay. Yes, Jishu. What are you asking? Okay, PN junction. Okay, PN junction means junction means what? Suppose Bhopal junction, Jaipur junction. What does it mean? Some station are only this station, but some has this junction, Jaipur junction, right? Gandhinagar station. There is no junction. Why? So one station is junction, second is nothing, because there is one line which is coming from that side and going through it. So that is only station. But junction means this side, both are meeting at that point. Okay, so some means two things are meeting at some point is known as junction. So what we are doing, we have p type and type material. We are joining. After joining, that point will be known as junction. So before meeting, there was mobile charge carriers. Okay, wrote here. You should see here like this. Okay, there was mobile charge carrier. Before that, I drawn this hole, and below that I have written immobile. So that hole is removed. So before meeting, all the charge carriers were mobile charge carriers. But after meeting, hole is positive, and is electron is negative charge. So positive and negative will meet each other. There will be recombination. After recombine with each other, it will become neutral. Neutral means immobile charge carrier. So you can see two lines. I have removed two lines, hole and electrons. Why? Because it will be recombined and will stop the recombination process. Okay? So this is PN junction. How it will work, we will understand in the next session, because we will use this diode in circuits as a switch. Okay, and this is the symbol of PN junction, triangle and bar. So this is the symbol which we will use in the circuit diagram. We will not use this block diagram. This is the structure. We use the symbol of anything in the circuit. Not got it? Jishu understood? Oh, okay. Thank you. Anything else to anyone? Any doubt? You can. Okay, so we will meet in the next session with the new unit and new topic. And still you have any doubt, you can ask me in the next session. Okay, don't worry. Okay, Meenal, you remind me in the beginning. Okay, I'll explain. I'll open that slide also, wherever you want to ask. Okay, Meenal, it's your duty to remind me. Okay, it's your duty. I'm giving you the duty. Okay, because I have we have so much tasks, so we generally forget. But if you ask, then I'll explain at the same time. I'll open that PPT. Then after I explain. Okay. Okay. So thank you so much. Thank you. You can leave. We will meet in the next session. Thank you so much. Happy learning. Thank you. Bye bye. Take care. Thank you.